Today's lesson we'll be talking about section 5.4, more trigonometric graphs than since the last section. This is the first part, so I'm breaking it into two parts where for the first part we'll talk about tangent and cotangent, and then for a second secant and cosecant. Now tangent and cotangent have a period of pi. So instead of the period of 2 pi over k that we use for sine and cosine, we'll use a value of pi over k instead, as we're switching stuff around. So that means our increments are already different, because if I have a period of pi and I divide that by 4, then that's where my increments that I get here come from. So I start with 0 and then work my way all the way to pi. So now for tangent, if I do this, remember we're taking y divided by x on our unit circle. So basically we're going to start from here and work our way around, but these ones work nice too, even though we're using pi over 4 and 3 pi over 4, because of the division at those points. You're taking the square root of 2 over 2 divided by the square root of 2 over 2, so we get 1. In that case, that's how you kind of get 1, kind of like what we did with sine and cosine when we're going all the way around the circle. So at 0, your point is 1 comma 0. So 0 divided by 1 for tangent is equal to 0. At pi over 4, I just stated it was square root of 2 over 2 divided by square root of 2 over 2. So that gives us a positive 1. Then pi over 2, remember it's 0 over 1. Here we're doing it's 1 divided by 0. So for that one, because you're dividing by 0, you can't do that. So that means that it's undefined at that point. And then 3 pi over 4 will be square root of 2 over 2 divided by negative square root of 2 over 2. So because of the negative, we'll get a negative 1. And then pi is negative 1 comma 0, so that's 0 divided by negative 1, so that gives me 0. Okay, so when I graph this on my graph over here, at 0 it's 0, at pi over 4 it's 1, now at pi over 2 it's undefined, so I can make a dashed vertical line. At 3 pi over 4 it's negative 1, and at pi it's 0 again. So here, when I look at tangent, all my lines always approach asymptotes, either going to infinity or coming from a negative infinity. So my graph for tangent would look something similar to what I'm doing right there. Okay, and cotangent will look very similar as well, but here it's x divided by y instead. So if I do the same thing at 0, there it's 1 divided by 0, because your x value is 1 and your y is 0, so that's undefined. Okay. At pi over 4, it's still square root of 2 over 2 divided by square root of 2 over 2, which is 1. Pi over 2, now here it's 0 divided by 1, so that gives me 0. And then 3 pi over 4 will be negative square root of 2 over 2 divided by square root of 2 over 2, so it gives me negative 1, and then pi will be negative 1 over 0, which is undefined again. So our graph for cotangent, and try to make sure that, let me use a different color for this one, just so you can see better. Try to make sure that you do draw your undefined line over the y-axis, because it's not, I know that it's hard to see, and you assume that just because it's the y-axis you don't have to write it, but please draw it, and you can either draw it to the side, or kind of alternate between sides if you want, kind of like that. Whatever you need to do to be able to do that, or draw your y-axis very light, and your x-axis, or your dashed line darker. For the rest of it, so pi over 4 is 1, pi over 2 is 0, and 3 pi over 4 is negative 1. So then my graph will look similar to tangent, but it will be flipped, and it will be moved over by a value of pi over 2 in all places. Okay? So now that we know how to do that, the general form, kind of like before, example 1 says the graph y equals 3 tangent of 2 times x minus pi over 2, parentheses, plus 1. So here, kind of like what we did with the sine and cosine values. So first we talk about our phase shift. So remember that means I'm moving to the right, so I'm going to do the opposite. So for my new x values, so usually I have 0, pi over 4, pi, and pi over 2, 3 pi over 2, and pi, oops, pi over 4. Now here you don't have to write the rest, let's just work on that first one. So let's ignore the rest of these, since we have a period change as well. So if I add pi over 2 to this first one, I get pi over 2. And then I also want to take the opposite of my period. So let's figure out what my new period will be. So if it's pi over k, I'm taking pi divided by 2. So now my new period is pi over 2. So I'll divide that by 4. So that gives me a pi over 8. So that's what I'm going to add to pi over 2 because that's my starting point. So okay, so here, start with pi over 2. And remember, we're not worried about those numbers. So add pi over 8 to each of these. So this is like 4/8, so we'll get 5/8. And I get 6/8, which is 3/4. And then add another 8, gives me 7 pi over 8. And then another 8 would give me pi. Okay, so that's my new period. These are my new x values that I'm going to plug in. Okay, so now here, you're going to plug it in into our function. Okay, so plugging in now remember it should emulate the original values that I started with. So I should kind of get or see a 0, pi over 4, pi over 2, 3 pi over 4, and pi when I do this. So pi over 2 minus pi over 2 is 0. 0 times 2 is 0. Tangent of 0 we already determined was 0. 0 times 3 is 0, plus 1 gives me 1. Then doing that same thing for 5 pi over 8. Gives me 5 pi over 8 minus pi over 2 gives me an 8th pi, times 2 is 1/4 pi. Tangent of pi over 4 is 1. 1 times 3 is 3, plus 1 is 4. Okay, so I'm going to do the same thing for all the others real quick. So plugging each of these values in, you will get the values of undefined, because 3 pi over 4 minus pi over 2 gives me pi over 4, which pi times 2 is pi over 2. And tangent of pi over 2 is undefined, so we'll say short does not exist. And then for tangent of, so 7 pi over 8 minus pi over 2 gives me 3 pi over 8 times 2 gives me 3 pi over 4. Tangent of 3 pi over 4 is -1. And then -1 times 3 is -3, plus 1 gives me -2. And then, as you can see, the pattern should be that I get 1 back. So pi minus pi over 2 is pi over 2, times 2 is pi, and then tangent of pi is 0, 0 times 3, 0, 0 plus 1 is 1. Okay, so then when I graph it, I get 1 for 0, or sorry, 1 for pi over 2, because that's where I started, and then 4 for 5 pi over 8, which would be right there. Undefined for 3 pi over 4, then negative 2 for 7 pi over 8, and then 1 for pi. So then my graph, if I just showed that period of 1, you could continue it on and do the same pattern over and over again. So here you'd have negative 2, and then undefined, and then 4, 1, if you wanted to. But for like tests and stuff, you would only have to show one cycle, which would be from the pi over 2 to the pi that we just showed. Okay. Now next one, we're doing 2 cotangent of 3x minus pi over 2. Now what I want to show for this one is that when you have a 3 inside, or the coefficient to x is not just 1, sorry for my son, he's just sitting in here talking. When I have a coefficient that's not 1, I need to factor it out. So I have a coefficient of 1, so I can figure out what that k value is, which is 3. So if I factor out the 3, that leaves me with x. Now remember that that's like saying division, so divide by 3. So then flip it around, so multiply by, multiply by 3. That'll get us pi over 6. So then that's my phase shift. So then here, remember, that's like saying right 3, or right pi over 6. So I'm going to add pi over 6 to my values. So let's start with that first one, so 0. So I add pi over 6, and then I apply my period to that. So in this case, my period is 3, or my k value is 3, so taking pi divided by the k value, so that would be pi divided by 3. So then my increments divided by 4 give me 12ths. Okay, so here, starting with pi over 6, I'm going to add pi over 12 to each one of these, or to pi over 6 in successive order. So that's like saying 2 pi over 12, so that gives me 3 pi over 12, which is the same thing as pi over 4. Okay, then 4 pi over 12, which is the same thing as saying pi over 3, and then 5 pi over 12, and then 6 pi over 12, which is the same thing as saying pi over 2. Okay, so here, using my function, and I'm going to use the one that I factored. So then I plug in pi over 6, and I'm going to do this for each, so to save us some time, so I'm going to quick pause. So now, doing the simple math, pi over 6 minus pi over 6 is 0, 0 times 3 is 0. Now cotangent, we already talked about it. The pattern is undefined, -1, 1, 0, -1, and then undefined again. So here, because we get cotangent of 0, that was undefined. Okay, so if you know that pattern, that's the same pattern it's always going to be. So cotangent should be of, let's say, pi over 4 in this case. So then cotangent of pi over 4 is 1. 1 times 2 is 2. And then cotangent of what this should be is pi over 2. And that gives me 0. So 0 times 2 is 0. And then this should be cotangent of 3 pi over 4, which is -1. So times 2 is -2. And then this should be cotangent of pi, which is undefined again, so that gives me does not exist. Okay, so then my graph should look like, so plotting my points, I get an undefined line here, and then at, that's at pi over 6. You're so used to 0. Sorry about that. So at pi over 6, it's undefined, and then at pi over 4, it would be 2, so it would be right here. And then pi over 3 is 0. And then at 5 pi over 12, it was -2.
Okay, and then at pi over 2 again is undefined. So then our graph will look like this. Okay, have fun.